Hi there, I'm Bruce Oliver. I'm a principal at DAS42, and today I'm going to be demoing our Infinite Improbability Drive. The Infinite Improbability Drive is a Snowflake-Native app that's designed really for two primary functions. The first is to serve as a central hub for certain novel solutions to common problems that our teams have run into and created quick solves for those novel problems. And the second function is to provide various project accelerators for our day-to-day work. There are things that we do all the time, every day, and the Infinite Improbability Drive is meant to serve as a toolkit and central hub for knocking out certain tasks really, really fast. The application runs entirely within a Snowflake account, so there's no external infrastructure, there's no data leaving the environment, no separate licensing. We install it once, and the team gets instant access to tools for data profiling, master data management, SQL accelerators, infrastructure automation, and really whatever else we think about. As we continue to scale this project or this tool, we'll be able to push any net new tooling from a central provider in our Snowflake account out to all of the consumers of that application. So as we make it better, all of the consumers of the app will also get those benefits. In terms of the architecture and why it kind of matters, like I mentioned, it's a Snowflake native app running all on Snowflake container services. So that means zero data movement. Every tool operates on your data exactly where it already lives. For example, the profiler is going to query your tables directly. The MDM engine is going to match records in place. Nothing gets extracted, copied, or sent to an external service. You don't have to worry about data movement or security concerns. All of the compute is consumer side, so the app runs on your compute pools. It consumes your credits. DAS42 never sees your data, never touches your compute. We send out the application. Our teams run it on your Snowflake environment. It's a one-click deployment. You install from a private listing right from the Snowflake marketplace, grant a few privileges, call a stored procedure, and the application starts up. To turn it down, it's another stored procedure to simply stop it. So very kind of drag and drop, click and play, if you will. We've also integrated a bunch of Snowflake's differentiating features like Cortex AI. So the SQL tools are using Snowflake Cortex for style conversion and semantic analysis, but again, nothing is ever leaving the Snowflake boundary. And there's an auto-suspend support for cost control. So your compute pools that get spun up are auto-suspended after idle periods, which means that you're only going to pay for the application, even if you forget to turn it off, if you're actively using the tools. Okay, so I'm over in Snowflake, and I just wanted to tee up what it looks like once you've installed the actual application. So once you've gone through the Snowflake marketplace, searched for DAS42 Infinite Improbability Drive, and pressed Git, you will get access to an application object that would look something like this, IID, whatever you called it. And within that application object, there's a number of different procedures, and these procedures are designed to help the user interact with the application in a seamless way. So the first thing that you would typically do after you've installed the app is run this start app command, which does everything in the background to spin up some compute pools, spin up some container services so the application can actually run. I've already run that previously before the demo started. It takes 3 to 5 minutes for everything to start up. So to save some time, I've already run this start app command. And if I wanted to check the status, for example, especially when the application is actually spinning up, I can use this helper get service status stored proc, which will actually show me kind of exactly what's coming from the logs from each of the containers under the hood. I can see that the status is ready. That's a good sign. So now I'll go ahead and run a get app URL, which will tell me the actual URL that I can use. You notice it's a Snowflake computing.app URL because, again, this is running all within your environment. And I can just go ahead and grab this URL and throw it in a browser, and it will load up the Infinite Improbability Drive. If that was the first time I'd ever done this, you would actually get prompted to go through the regular Snowflake authentication flow. So you'd probably sign in with SSO, and then you'd get landed right here. And so yeah, this is it. This is the Infinite Improbability Drive. Like I mentioned, the goal here is kind of twofold. Create a central repository or central hub to solve common problems that we run into, things like master data management or, Foundation 42 for creating for rapidly spinning up Snowflake objects like databases, schemas, all the RBAC that goes under the hood, or even Constructor Fleet, which is our approach to rapidly generating a bunch of DBT for our bronze and silver layers. So these are the things that we run into at a broad scale, kind of bigger, hairier problems on all of our projects. And so we wanted this this tool to be a hub for any of the novel solutions that we've come up to solve those big common problems. All three of these specific tiles, if you will, MDM42, Foundation 42, and the Constructor Fleet are actually pretty in-depth, complex solutions, and we've recorded separate videos for each one of them specifically. So for today, I'm just going to focus on the application as a whole, as well as some of these smaller tools, and they're faster and easier to demo all at once. But just as a note, if you're interested by what these are, and I'll tee up kind of what they are, but if you're interested to learn further, we've recorded a full video for those, and you'll be able to find them on our website. Okay, so for today, we're going to focus really on the data profiler tool, the SQL Style Guide Converter, and the Variant Unpacker. These are the types of tools that really serve as the second function of this application, which is to be a hub for project accelerators in our day-to-day work. So for example, let's walk through a scenario where I'm a data engineer on a project, and usually the first thing that we do on a brand new Snowflake engagement is we're probably going out and getting a bunch of data from different sources. Maybe I'm using Fivetran to do that. Maybe I had to create custom pipelines. But the short of it is I've gone out and I've gotten a brand new data source that I'm not intimately familiar with. This is the first time that I'm seeing this data. And it'd be really, really nice if I could get a kind of a mental model and a head start on understanding the content of that data. That's what the data profiler is for. So if I go ahead and click in here, the first thing that I'm prompted for is, hey, what database and schema do I want to analyze? So I've set up a demo data set. It's sort of your obligatory e-commerce example. So we've got customers, orders, order items, products, product reviews, and shipping addresses. But I've never seen this data before. It's a brand new system, and I just want to try to understand and wrap my head around what's in there. What are my big tables? What are my wide tables? What are some of the primary keys? And what are maybe some of the relationships across these tables? I can opt into profiling as many tables as I want to. In this case, I'm going to do all of them. But you could see a world where maybe you're working with a data source that when it first comes in, it's hundreds of tables, and you want to take a more targeted view. You would have the ability to kind of self-select which tables are actually profiled. And then I'm just going to hit run. And under the hood here, the application comes pre-canned with a number of different stored procedures that are going to kick off. And they can be configured to take in, variable database and schema input arguments. And we basically have a stored procedure for each one of these high-level tabs, if you will. So we'll have a stored procedure that goes out and gets high-level metadata, a stored procedure that goes and profiles all the columns, a stored procedure that goes hunting and trying to find high-confidence primary keys, another one that goes and tries to find high-confidence relationships across those tables, and then another stored procedure that does a AI-supported summary. So it basically takes a look at the data that's there, looks at the column names, looks at the actual table name, and takes an educated guess about what it might think is in the table, just for some human readable grounding for the data engineer. And then as each one of these different tasks completes, the corresponding visual tab at the bottom will populate. So as you can see, metadata has finished and columns is finished, and we're actually seeing some content flow through. So while these continue to chug, I'll start stepping through, the tabs that I've already rendered. So from an overview, that's what it sounds like. Just a grounding on overall, what are we looking at? In this case, it's a small demo data set. So I've got 6 tables, 1.5 thousand rows, about 85 kilobytes of storage. My largest table is the customers table. My widest table is the orders table. And this seems really elementary, but sometimes it can be super helpful to just ground yourself on what is the biggest table? How much data am I really working with here? That's what the overview tab is meant to do. The next part is a deeper dive on each one of the tables and their columns. So I can filter down to any of the 6 tables that I've selected here. If I wanted to look at a more specific spot. But let's start with customers, for example. And now I can see in the customers table, we've got all these different columns. And for each one of those columns, I get this nice profile. So I can see kind of across the board here, this customer ID. So we're expecting these, my human brain can kind of say that's probably the primary key. It should be fully unique, and I'm going to have a really wide value distribution. But there's also things like status, where there's really only 3 distinct values, really low cardinality. And I can see even off the bat, I can see, okay, like most of the customers that are in here are active, but there's a handful that are inactive or suspended. So I'm getting context as I dig through these things. Next up would be my primary keys. This is one of the first things that every data engineer needs to do when they're working with a new data source, is understand what are the unique keys. What are these? These are always going to be really, really important for my downstream transformation logic or querying. And so what the stored procedure has done is gone through and using some combination of unique and completeness characteristics of each column. It's giving us a high level estimation on how confident it is that a given column is a primary key in that table. So again, it's demo data set, so it's fairly clear to my brain that maybe customer ID or order ID is going to be the primary key, but this gives you a programmatic approach to that, even when the column names aren't as clear, or especially if it's a really large, hairy data set. So as I scroll through, for each table, I've got a really clean indication of what may be the primary key. And of course, I have to do some work to validate this, but it's just helping me get started a lot faster than if I was just having to query tables one by one by one. This next part is, I think, kind of the most valuable to me, at least, is the ability to start to identify how might these tables relate to one another. E-commerce is typically pretty common. Relationships, right? Like you can go from customer to order item to product, what have you. Like this is an example that every data engineer is pretty familiar with. But imagine that it's a brand new data source for a system that you've never seen before, and having a one leg up or a head start on, okay, this random table actually seems to have a high confidence join to this other random table. This should really shave off analysis time as you get familiar with a brand new data source. So in this case, it's saying that, hey, I've got a really high confidence match that the customers are going to join to the orders table on customer ID. Sure. That order item is going to join to products on product ID, and so on and so forth. And all of this kind of analysis that I'd have to do normally on my own and attempting left joins and seeing counts, all of that is I've got a head start there. And finally, we have our AI summaries. So sometimes it can be helpful to just be like, what might be in here? What does AI think? It can be a grounding kind of exercise to say, okay, I've got all these tables. Let me get a human readable summary of what might be in here so that I could have a bit of a head start on my analysis here. So that is the data profiler tool. And again, the intent is just to speed up the process and onboarding for getting used to a new data source. Moving on, we're going to talk next about a topic that's near and dear to every person who has ever reviewed a PR, especially for companies that have a common style guide or a constant group of different developers that you're working with, and you're trying to establish some form of uniformity across SQL style guides. At DAS42, we've always been really opinionated about, it's important to write really consistent, clean, formatted SQL for a number of different reasons. It's, it gives a polish to the end deliverable, but it also helps DAS42 team members identify, did a DAS42 team member work on this code? It's a quick, almost like a watermark to say, okay, we worked on this. And it's easy to read. It's easier for everybody to read if they're seeing the same type of format all the time. Having said that, it can be hard to enforce, and sometimes you forget, and especially if it's a long SQL style guide with a bunch of different rules and ideas about how you should do this, particularly when you're just getting started or you're a brand new hire at DAS42, it can be a lot to adjust to. So that's why we designed the SQL Style Guide Converter, which under the hood is using a Cortex search service and is plugged straight into a chunked unstructured document that is the DAS42 SQL Style Guide. And what I can do is I could paste any SQL in here. It could be as ugly as possible. And when I press convert to DAS42 style, it will do the work to convert the SQL and do exactly the pretty style that we expect from our DAS42 developers. I can even, if I want to, I can ask questions of the style guide. So if I wasn't quite sure, if I'm working on a pull request and all the review says is SQL style guide, I could say, what? What does that mean? And I could go and have a natural language question, question and answer with the document itself, right? So for example, DAS42, I know because I work here that we're really big on using CTEs instead of subqueries. But if I was brand new and I said, what is our stance on subqueries? Now the search agent is going to go and pull for the relevant chunks in the unstructured document, and it's going to actually answer my question in natural language. and I'll be able to see really clearly that, hey, like according to the DAS42 SQL Style Guide, CTEs is what we should be using instead of subqueries. There's a couple times when maybe it doesn't make sense to do, when subqueries would be allowed, but in general, we want you to be using CTEs. So as a quick example, quick and dirty, this could be, you could get as complex as you want with this, but for the purposes of the demo, I'll just do something like select column 1, column 2, column 3 from table name, and I'll even throw in a left join, table 2. I guess I need some aliases, bear with me here. Just something all nasty, it's hard to read that, right? It's all in one big line. Let me go ahead and convert it to the DAS42 style guide, and I'll get what should be a much cleaner, easier to read. Nice, I know how to read this. I can throw this in. You can see how this might get especially useful if you've got a really, really big query that's completely written in a different format than you're used to. You can just cut and paste it, throw it in this, and you're off to the races. That's our SQL Style Guide Converter. Okay, so the next tool that I want to talk about is our Variant Unpacker. This is a tile that I'm really excited about having because one of the most arduous and annoying processes that a data engineer has to go through, especially someone who works with Snowflake a lot, is this concept of unpacking a variant object. So to set the scene a little bit, let's imagine that we have a brand new data source flowing into our bronze layer in Snowflake, and the only way to get that data is via API, like a REST API. And so that data is coming back in, say, JSON format, some semi-structured format. And as you may know, if you work with Snowflake a lot, Snowflake has outstanding support for semi-structured data types. You can use their data type called variant, which basically is a housing ground for any semi-structured object. So it would look, something like this. A common bronze architecture is to basically bring everything in variant structure in the semi-structured payload, and just allows Snowflake with this variant column to just kind of house everything. Which is great because I've got the data in Snowflake, and now I kind of just need to unpack it and make it look like a regular table that I could execute common SQL on and work through a medallion architecture that way. Before LLMs, this was particularly annoying as a data engineer, because I would have to do something where I would basically say like select, payload amount number as amount from API responses. It's like, cool, that seems to be working. And you would just chug away at this, right? I would rerun my query. I'd look at this, and I would just keep chugging one by one. I would say that's a create. I would have to say payload created string as created. And I'd run that and be like, it's actually a timestamp, try to timestamp. And you can see how this could get really boring and really take a long time and not be super fun. Then of course LLMs came out, and they got better and better and better, and it became very viable for me to basically just copy this whole thing, throw it in Claude, throw it in ChatGPT, and say, hey, take this payload and convert it so that and give me this Snowflake compliant SQL to unpack it into a tabular format or something. And that works pretty well. However, those tools typically do things differently from run to run, right? It's an LLM, so you don't always get the exact same response back. So you get different styles, different assumptions. And I've also found that the LLMs are not very good at identifying nested arrays and then doing like a lateral flatten on top of that. So there's a consistency problem, and there's also like a complexity ceiling that you kind of hit with like automated variant unpack using an LLM. And so that's where our thinking was with creating the actual tool for it, is do it exactly the way that we want it, do it programmatically so that we get a consistent input output every single time. And then, oh, by the way, live it in Snowflake so that you could put it right where the data is, where that raw data is, and you could really be looking at some accelerations in your workflows. So for example, there's a couple different ways to use this tool. I can do it where I just give it one record and it will spit out the transform SQL for me. So, maybe I haven't even ingested the data to Snowflake yet, but I have the raw payloads and I want to start getting ahead of the SQL. I don't know. There's different flows that you get into as an engineer. I could just take the raw payload, whether that's coming from Postman or from a Python script, and I could throw it right in as the JSON input. And I can make sure that it kind of plays well with my SQL. So I'll say, I gotta give it the right column name. So I'll say payload here, and I'll generate the SQL. And just like that, it immediately creates 2 queries for me with a bunch of helpful metadata around kind of the assumptions that it's making and the paths that it's walking. But the really cool thing here is, one, it quickly generated what I'm looking for in a format that's expected. And it did a nice job intuiting, for the most part, the data types that I wanted to cast to. But it also identified that there was an array in that response, and it automatically generated the lateral flatten that I would need to basically unwind that array, which is something that the LLMs, like I said, don't do a very good job at unless you really prompt them to. So I can grab this just to show kind of exactly where we're going here. And I could say API responses, and I can run this, and just like that, I've got this clean, no, it's no longer JSON, right? It's this very clean tabular format that you could see me materializing as my silver layer. And then from gold, I'm just doing, common left joins. And that happened really, really quickly. I didn't have to go talk to an LLM. I just cut and paste. The other thing that I really like about this tool is I can also point it directly at a table in Snowflake that already has a variant column. And the big advantage here is it's very common, and I've been bit by this a number of times, to like the one record that you picked from maybe this table to throw in as just a straight copy and paste like I just did. Sometimes it's missing some of the keys that other records in that table have, right? Sometimes APIs will return some of the fields in a JSON blob for one structure, and then other fields for another endpoint, or what have you. So you run into little nuances where you don't do the complete unpack until you're down into the silver layer, and you realize, like, oh, the business is expecting there to be more columns than there already is, and it's just because I picked a wrong sample record to auto generate my SQL. And so what this is doing is actually pointing it entirely at a column, and it will robustly check kind of across the board what are all the different permutations of keys, so that I know that I get a comprehensive output, is the gist here. So I'm going to just point this at a database, schema, and table. So I've got some sample data queued up here. We'll use the API responses. I'll tell it that my payload, and you can see that these were like auto loaded, so I'm not having to do a lot of thinking, and I'll go ahead and generate. And I got a nice clean payload that way, or a nice clean unpack that way. And then I can just keep working, right? Like, I know that maybe I've got another table, and in this case, the variant column is slightly different. Like, we're holding it in event data instead of payload. This already sees that. It's using information schema to know what the different columns are. And I can go ahead and get that SQL really, really quickly. So yeah, hopefully you could see how much of an accelerator this would be in terms of working with a new data source, because I just have to get it into Snowflake. Then I'm going to use this tool to quickly generate the transformation logic, maybe throw it in dbt or whatever transformation tool I'm using. And I'm going to go a lot faster than I would if I didn't have this tool. So the last thing that I want to talk about for the Infinite Improbability Drive today is the concept that this is going to continue to grow. For example, we have plans to roll out a SQL syntax converter, which will allow you to convert from various SQL engine dialects straight to Snowflake compatible syntax. So for example, converting from BigQuery syntax to Snowflake, from Postgres to Snowflake, from Microsoft SQL to Snowflake. We're kind of envisioning, this being a big accelerator for our teams if we're ever doing migration work from a different data warehousing engine than Snowflake. And the reason that I bring it up is because all that will happen is one day we're going to roll out this tool, and any of the consumers of this application, anybody who's already installed it, it will auto ship out to them. So the next time that they load up the application, they'll actually have access to the SQL syntax converter in all its glory instead of this coming soon banner. And the same is true for as we continue to scale and add tiles. Our teams are every day finding new ways to accelerate our work. And we're using this Infinite Improbability Drive as the central hub to make sure to democratize access to all of those accelerators. So the upshot is it's kind of going to be ever improving. And as long as you're a consumer of the application and you have it, you'll get to take advantage of any improvements that roll out as we go here. All right, so to wrap things up, this was a demonstration of DAS42's Infinite Improbability Drive. It's a Snowflake native app, and it is our internal hub for all things speed, whether it's, solving a novel problem like MDM or spinning up a brand new Snowflake full-fledged architecture, or whether it's a really tactical, in the weeds, day-by-day accelerator like unpacking, a variant column. 100% of it lives in Snowflake. You got one-time install, zero data movement, and everything's running right in Snowflake. That's the Infinite Improbability Drive. If you're interested in taking advantage of this tool, please reach out to DAS42, and we'd be happy to talk to you about it. Thank you.